For 6.5, we've actually hinted at this before, the concept of slope. Okay. Using slope to draw lines. Understanding slope as a rate of change. Solving problems involving slope. Title's called Slope. You figure that the learning outcomes have something to do with slope. You should look at this at some point. Look at the textbook, because the pictures are obviously probably a lot nicer than I'm going to scribble here. The one thing, talking about what the slope of a line is, we have talked about it before, but not with specific numbers or anything like that. If you have, let's make 3 little graphs here, first of all. We've looked at up to this point. We've looked at a line going up to the right, or a line going down to the right, or a line that's straight across like that. If those were graphs of distance versus time, what's happening with distance versus time in each thing? The first one, what's happening with your distance as time goes by? It's increasing, right? It's going up. If this is distance and this is time in each case, this first one is positive slope. The rate of change is going up. The rate is positive. Your distance is increasing if it happened to be distance. This one is a negative slope. Okay, I'm going to put here, the first one goes up, second one goes down. That's the first thing to know about slope. What about the third one? What about that? 0. The slope is 0, right? 0 slope. If that was distance time graph, what would that mean? It's not moving. Like you're not changing your distance. You're not moving, right? Flat. I don't know what you're going to put here. We're going to leave a space here to write out a more formal definition of slope in a second, but let's look at this thing. The slope between 2 points. If you have 2 points here, okay, let's make it so that it is a number that is going to work. Okay, I guess that one works fine. Between those 2 points there, if I'm going to look at that thing, let's make it a bit bigger so you can see it. The slope between those 2 points is how steep the line is. If I move this down, there the slope is 0, there the slope's negative, right? There the slope is positive. The line can either be going up to the right, flat, down to the right. You could make it a vertical line like this if you want, right? It can either be vertical, horizontal, going up or going down. We're always going to look at it as left to right when we try and work with lines like this. The slope of the line is going to be a measure of how steep it is. One way of measuring how steep it is to look at how much do you change horizontally as compared to how much you change vertically, right? How far across do you go compared to how far up and down you go? You can talk about the change in X and the change in Y. Sometimes, and in the book, you probably see this little triangle. You might have seen that in science before. That little triangle is a delta, a letter delta. It's a Greek letter. It represents change. It's a shorthand for change. So when you see delta X, it means change in X. And delta Y means change in Y. From that point to that point, the change in X is 6. When you go to the right 6, you go up 3. The slope is if you take this number and divide by this number. The slope is going to be that much. What the slope is if you divide these two numbers, 3 divided by 6, it gives you the same as 0.5 for every 1, right? 3 compared to 6 is the same as 0.5 compared to 1. So you say the slope is 0.5 or 1 over 2, 1/2. A slope of 1/2 means 3 for every 6, or it would be the same as if it was there, 2 for every 4, or it would be the same as if it was 1 for every 2, right? It's getting crowded in there, but 1 for 2, 1/2. You can say the slope is 1/2 there, or 0.5. Okay, we'll go back to this one. I'm going to copy a picture of that down here, and you should maybe do the same thing here. draw some kind of a simple picture where you have something that looks like that. It doesn't even matter if you have the axes on there or not, but you need something like that. I need to undo that for a second. Because I need to move this back up there. All right, so copy this. I would say draw a picture of that, and then you can write some stuff down about slope. I'm also going to pause this while we write this down. Okay, so you have a situation where you have, I would put a kind of a definition of this. This is change in x, and this one up here was change in y. That's what that delta means. Basically, the slope, and this is a formula that's on the formula sheet you get on the exam. It'll say whatever the change in y is compared to whatever the change in x is. If this was a hill you're hiking up, and this was how many kilometers you've walked, and this is how many. Well, it's not going to be, the numbers aren't going to be right. I'll draw a different picture up here for this. Let's say you're hiking on something like this, and on the map you went along 5 kilometers, and in those 5 kilometers you went up 300 meters. The slope in that situation would be 300 meters per 5 kilometers. In 5 kilometers you went up 300 meters. That's what the slope represents. It's a comparison of how far up or down you go to how far along you go. Okay? So you see this on here. You might also see, I don't know if it's written on the formula sheet, I have to look. Some people call this, the change in y, they call it the rise, how far up it goes. And some people call this the run, how far along you go. So some people would tell you that slope equals rise over run. You can remember it either way, or both ways would be good. Think of it as change in y over change in x, or rise over run. Or you can write a formula. You'll see a formula on the formula sheet that looks something like this. If you have 2 points here, you can figure out the slope just from the points without even seeing the picture. Okay, let me write the points down here. It goes from 1, 1 up to 7, 4. If you call each of those points something, if you call this x1, y1, and you call this x2, y2, you can write a formula for slope just using those things. How could I work out that this distance is 3 from the numbers that are in those points? How can I work out the 3? From these 2 points? Where does the 3 come up? The 3 is the difference in between the two y values, right? That's delta y. The change in y is the difference between the y coordinates. Difference between y coordinates. Y coordinates. So in other words, you could write something here that says difference in y coordinates, or in other words, if I took y2 and minus y1, right? This is 4. Let's look at this. I didn't copy the scale, but if this is 4 and this is 1, obviously the difference between those is 3, right? If you subtract those two, 4 minus 1. And then if you want the change in x, how can I find the change in x? x2 minus x1, right? Delta x is the difference in the x coordinates. Delta x is difference in x coordinates. If you subtract them, right? 7 minus 1 gives you the 6, right? This thing is 4 minus 1 This thing is 7 minus 1. So you can write a formula that says y2 minus y1 over x2 minus x1. That's another formula that's on the formula sheet. Any of those will give you what the slope is. What if the 2 points were, well, I guess I should leave it there for a sec. What if the points were, the second one was below the first one? What's going to happen here? What happens to the length of the arrows? Let's go to here. Let's make sense of what's shown in the picture here now. The slope it shows in there is, I'll write it over here, I guess. Let's do some different numbers here. 2 2s, let's put up here. 3 1. 1 3. No, let's go one more here. Let's go one more. Let's go one more. Hoping to have different, so all 4 numbers are different so we don't get mixed up. How about that? It's huge, but whatever. For those values there, you have change in x is 5. When you go 5 to the right, the line drops down 10, right? You lose 10. This thing shows, this program here shows the distances always as positive, but how should we represent this distance here? The change in y is not positive 10. What is it? Negative 10. This should be written as negative 10. The slope is negative 2. What that means is for every 1 over, it's going 2 down. 1 over, 2 down, 1 over, 2 down. Every time here, you're going 2 down for every 1 over. The slope's negative when it's going down because you go over and you end up going down, not up. Okay? If you wanted to work out the slope of those 2 points, even if you don't have the picture, what was the first point? Let's go back there after all that fiddling around getting the points right. The first point is 1 3. What's the second point? 6 negative 7. 6 negative 7. If you want to work out the slope from that, you can write it however you want. You can say delta y over delta x. I personally happen to like that one the best because then you can just say the difference between these two. You can subtract it if you want, if you're not sure. It goes down how many there? From 3 to negative 7, what happens? It goes down 10, right? So it's negative 10. And from 1 to 6, what happens there? Those are x coordinates, so I'm going to use the word over. When it goes over 5, it goes down 10. So it's negative 10 for 5 across. Okay? You can get it by just thinking about where the points are on a graph. Slope is negative 2. Negative 2 is the same as saying negative 2 over 1. Usually you just say negative 2. If you want to use the formula that says y2 minus y1 over x2 minus x1, you can do that because you can just say x2 is negative 7, y2 is negative 7, x2 is 3, x2 is 6, x1 is 1. Negative 10 over 5 gives you the same thing, right? Negative 2. However you want to figure out slope is fine with me. Okay? Now that's the concept of slope. We have to be able to apply it to real situations here. The first example in the textbook talks about positive, negative, well, or 0. I don't think there's any positives or negatives, or there's no zeros in that picture, but classifying slopes of lines, there's a bunch. It doesn't actually say find the slope. It just says classify them as positive, negative, or neither. You could go one step further and you could say 0, or there's one other possibility for the slope. One other possibility here you should know. For this line here, let's Let's get rid of all that stuff. What about if we had a line that was starting somewhere here and we did this to it? What about if we did this? Stop there. Or actually, let's do this one first. What did you say the slope of that one was? It's 0 because when you go over 6, what's happened? How far up or down have you gone? Nothing, right? The change in y is 0. It hasn't gone up at all or down at all. It's 0 divided by 6. If you subtract these, if you subtract numbers that are the same, -3 minus -3, what do you get? 0, right? 0 divided by 6 is 0. If you change it now, of course, the numbers are like that. But what about if I collapse it so that this line is going up like this? Now what's happened? It's gone up 7, but how far across has it gone? 0, right? If I write the slope of that, 7 divided by 0, what is that going to equal? 7 divided by 0? What is 7 divided by 0? Well, it's either infinity or negative infinity, because I can make that same line by doing this, right? I can make that line exactly the same. It seems like it should be infinity, but it could also be negative infinity, right? Because you could think of it as, you can't tell which one's the first point and which one's the second point if it's straight up and down, right? You could say you've gone across nothing and down 7, which would be negative infinity. Or you could say you've gone up 7 or 6 or whatever it is, right? You could say you've gone up a bunch for 0 across. 7. If delta x is 0, the slope is undefined. If I show the slope here, it's going to say, it's not going to say anything because it's undefined. It's going to disappear. You see what happens with the slope as you make this steeper and steeper? Look at, for 1 unit, it's huge, right? It becomes this huge number. It's going to say undefined, is going to disappear there. From one side of it, it looks like it should be negative infinity. From one side, it looks like it should be positive infinity. That's why it's undefined. So something else you should know here is, I can't remember if I put it in here somewhere, is 0 slope. This has 0 slope. You should probably make a note of that somewhere. 0 slop. That handwriting looks like slop, but 0 slope. Vertical line, undefined slope. The slope is undefined. Okay, for a vertical line. And slope is 0 for a horizontal line. Oh no, where'd that go? Horizontal line. Okay? That's essentially what's happening in this section. Okay? The only other thing you need to know is if you're dividing things that have the same units, feet and feet. If you're dividing things that have the same units, like here, we can even do this example together here. This roof goes up. If we make this a really thick line so you can see it, it goes up 10 feet. 10 feet. That's what delta y is. It goes up 10 feet. I guess I didn't need it to be that thick. It goes up 10 feet when it goes how far across here? 24 feet, right? That's what delta x is. You could argue whether it's going uphill or downhill and whether it's negative or positive. In a situation like this, you're not going to call it negative something. But the slope, or what they call the pitch, is, when you're talking about roofs, delta y over delta x. The vertical always goes on the top. Rise over run. Rise is on the top, right? The vertical is on the top. It goes up 10 feet for every 24 feet across. What does that divide to? Anybody know? What does that divide to? Can somebody divide that for me? Roughly 0.41? Okay, roughly 0.42. What would the units be here? If you're dividing feet divided by feet, what are the units? This is a ratio because it compares two things that have the same units. Whoops, since units are the same. What this means is it goes up 0.42 feet for every 1 foot across. It means when you go 1 foot across here, I'm going to draw it, 1 foot this way, it goes up 0.42 feet. That's what that slope means. It's how far up you go for 1 foot across. It's a ratio since the units are the same. The slope has no units on it. No units on this slope, right? Sometimes the slope is going to have units. That's what it is. Explain the meaning of your answer. If, however, we had something where it was something different, okay? I can't remember if we have something later on here, if I can skip to this. Those are easy, just figuring out slope. That's pretty mechanical for you. Here's something where the units are different, okay? I'm assuming you are going to be able to go through and do example 3 and 4, nice and easy, especially if you have the textbook to refer to. But this is something where the graph has, there's different units here and here, okay? The roof had the same units, so the slope was a ratio. This is saying for that much across, how much does this change? What are the units on the rise and the run here? We're going to say delta. Well, actually, I'm not going to use y here. I'm going to use d and t, right? What is the slope equal to here? I'm not going to put delta y and delta x. I'm going to put delta. What's the vertical? What's the vertical change here? Delta. Make this bigger. What's the vertical change here? D, right? The vertical thing is D. This is a D. So you can call it delta D. What's the horizontal change? Delta T, right? For time. Change in distance over change in time. That's what the slope is. The slope is change in distance, change in time. Change in distance, change in time. So if you're working out that slope, you can use the 2 points here, right? If you want to know the change in distance, you can look at the start and end distance, right? How far did they go? They went from 500 meters to 1,000 meters. You can subtract that if you can't figure out what it is in your head, right? You could say 1,000 minus 500 if you want. I'm going to write it down, but you don't have to. And this is meters, right? 1,000 meters minus 500. How long did it take for that to happen? From 85 seconds to 180 seconds, right? 180 seconds minus 85 seconds. It's really too bad that it wasn't a nice number there, right? Or if you can see that it was 500 meters in, how many seconds was that? A lot. Well, if it was 180 minus 80, it would be 100 seconds. So it's 180 minus 85, it's 95 seconds. On one hand, I'm saying it's too bad that wasn't 100 because it'd be so nice and easy to divide. If that was 100 seconds there, what would the slope represent? Or what would the slope be? It would be a 500 divided by 100. It'd be 5, right? Sorry. It'd be, if this was 100 on the bottom. I put the wrong unit there, didn't I? What should that be on the bottom? Seconds, right? 500 meters, 100 seconds is 5. Are these units aren't the same. They don't cancel out the same way the feet did in the previous one. The units would be meters per second. This is going to give us, can someone divide that? It's 5 point something. Anybody know what it is? 5.1 maybe? 500 divided by 95, what is it? 5.26. So 5.3 if we're dividing it? Meters per second. It says here, what are the units? including the units. Those are the units. The units are different here, right? Let's put a note here that these two things have different units. Units are different. That means the slope is a rate, not a ratio. Slope is a rate, not a ratio. It has units. What are the units here again on the slope? The slope is what? Here the units are meters per second. What does the slope in this situation represent? The slope of a distance time graph, meters per second, what is that? The slope is what is the slope? It's the speed or the velocity. It's how fast they're changing. Okay? Now, that's kind of a lot of information, but it's one central concept. For any of these things here, I want you to work these examples and make sure you're understanding the concepts as you go. We've done a few of them together, not all of them. You should be able to whip through quite a few of those examples in the time that you have left. That's what I'm thinking. Okay? Can you get going on that? You should leave here with the examples mostly done or almost mostly done.